So today we're going to explore a lot of different areas in terms of how BIM projects can be connect to an asset management system and exchange information between the two systems bidirectionally. So we're seeing more and more in the industry how the connections between BIM and asset management are not only becoming mainstream, but are really starting to become critical to operations. We're going to take a look at the software in a few minutes. I have a few slides I want to go through just to sort of recap where we are in terms of the industry, how we got to where we are today, and then how the software ModelStream allows us to fix some of the issues that we're seeing in the industry. I will point out in the webinar, if you have questions, there's a question panel on your control panel there. You can ask questions, and then we'll address those questions at the end of the presentation. So a little bit about Microdesk. So we are a global AECO industry consulting firm. We've been around since 1994, about a dozen offices, dozen physical locations across the US and the UK, but we have projects and operations that we work in around the world. About 140 or so consulting specialists and software developers. That number is always a little in flux because it's changing on a month-to-month basis as we grow. The key thing to understand about us is that we are both IBM business partners as well as Autodesk partners. And that allows us to take a look at how information flows from the design and the construction stages all the way into operations and maintenance. And really, when we look at that flow of information, you'll see later on ModelStream is really a critical linchpin in that flow of information. I mean, our services are then, structured accordingly. So we have services in the area of as-built modeling, which is where we do like LOD, level of detail, 500 model development, shop drawing, integration into Revit models, construction services, where we'll do the construction coordination work, BIM execution plans, managed services, and then enterprise asset management, which is my area there, which is connecting the BIM to FM, the strategic planning, Maximo design and implementation. The presenters that we have today are myself, George Broadbent, the Director of Asset Management. As you see, I've got 20 some odd years there in enterprise systems experience. That's from content management, records management, asset management. And the common thread there is that it's all about how do you manage the information across the enterprise and get the right information to the right people at the right time. We also have on the line Steve Martin, our Vice President of Software Development. Steve, if you want to introduce yourself.
Sure. Yep. Hi, this is Steve. As it says here, I've been with Microdesk for over 15 years, leading our software development efforts for custom development as well as the product ModelStream, which we'll be showing today. And most of my focus has been on integrating CAD design information, now BIM information, also GIS, but taking that body of data and linking it to enterprise asset management.
Excellent. And we also have on the line with us Andy Tess. He's one of our senior Maximo consultants, whose primary job is working in the Maximo environment and looking at how we can use the data that's coming out of construction and deliver an effective system for operations and maintenance. Andy, do you want to introduce yourself? I gave you a little bit there. But...
Yep, Andrew Tess. I come with a background from higher education operations, both IT and physical plant, and I've been primarily using Maximo for close to a decade now.
Excellent. So the webinar today is broken down into three basic topics that we're going to be covering. So first topic is really the cost factors and BIM in operations, and then the operations issues with the data. So we're going to walk through a few slides in that area there. And then, then the next section will be the actual ModelStream demonstration. And we'll look through how the platform works, the navigation, and get an understanding of what we can use the ModelStream software for. And then the last part is, we'll bring it all back together again, and we'll look at how the cost impact works with the ModelStream software, how this is going to benefit operations, and use this information going forward. So with that, what are we looking at? We have, ModelStream for Maximo is our solution to bridge that gap between facilities management and the construction world. Now, the graph that you see here is a couple of the more industry typical graphs that you would see. The bottom one is the traditional workflow, which is a sawtooth pattern graph. And then the second one, the red line, is supposed to be the idealized BIM workflow, where everything flows very smoothly from one stage, planning, design, construction, and into operations. But the reality is that we see is that there's actually a dip that occurs in that transition from construction into operations as a part of the BIM workflow. And that dip is as severe as the traditional manual process. So we have to find a way to be able to bridge that gap and be able to move that information over seamlessly. Now, the cost that we're looking at here of using either that sawtooth pattern or not having the information go from one area to the next is as follows. So we spend, in the traditional workflow, 10 cents per square foot understanding the project closeout packages. So that's really being able to decipher all the information that's coming through the closeout process and make that information available to operations and maintenance. And then we spend 23 cents per square foot annually just looking for information. And this statistic here actually crosses many different areas. Whether you have enterprise content management, asset management, anything like that. When you have your staff going out and searching for information, this is about what you're spending on a per square foot basis across your entire organization. So why, when you have critical assets that will cost you money if the assets are down, would you want to be spending money looking for the information to repair the assets that are in question? And then, what we know about the BIM process is that we can save 10% on the contract value through clash detection in the design stage. So when we transition from design to construction, we run the clash detections, and it's been well documented over the years that it's about a 10% savings on the contract value, and through avoidance of change orders and just improved construction sequencing. And then we also know that the BIM process in construction will save us 7% off of the construction project timeline. So that's roughly 1 month for every 16 months of construction, which is a significant amount of time if you're looking at a manufacturing facility or some facility that you want to get online to actually start producing revenue for your organization. 1 month is a large amount of money, and so the BIM process we know will actually save us that amount of time in the construction process. And then through a study that we did with Stanford University Healthcare, we found that by having the BIM models in operations and available to the facility operators, we can now save 5% annually on the operations cost. And this is a sizable number given the size of the operations cost, plus the fact that it's a recurring savings. And so when you look at the overall spread of information, dollars over the life cycle of the design, construction, and operations, a small percentage of your overall dollars is spent in design and construction, but the largest expenditure that you have is in operations. And you're going to be operating this facility for 20, maybe 30, 40 years. So if we can save 5% on your annual operations, that's a sizable amount of money that you're now savings. And we're going to show you really how do we get to that point? How do we make that possible? But what are we talking about? What's the downside, so to speak, if we don't do this? So we look at the traditional data transition timeline. And so what we have here is at day one, which is the start of operations, that's at the end of construction. So the end of major construction starts operations, and operations is looking for the O&M manuals, the cut sheets, the equipment specifications, equipment lists, just a general list. They're looking for this information at the beginning of the operations period so that they can start to shape how their work is going to begin. But the problem is that there's a time for the contract closeout where they're preparing deliverables and they're doing some kind of construction closeout, and that is some number of months after the end of major construction. But in the meantime, what's going to happen is that the operations and maintenance staff is going to go ahead and survey the facility. They're going to go to the manufacturers and get the O&M manuals. They're going to build out their preventive maintenance routines. And then this is the most costly item here. They're going to go ahead and replace the equipment that has failed. Now, the challenge here is that if they're replacing equipment that's failed, that means that they're not using who's providing the warranty, or they may be interfering with the construction closeout process. It's just not coordinated, and you're going to wind up spending a lot more money than you need to. And then at some point during the process, we estimate that's anywhere from 12 to 18 months. There's an operational data delivery. And unfortunately, a lot of times that data delivery will look like the picture in the upper right there, where it's a bunch of boxes, paper, rolled up drawings that gets delivered on a pallet, and now operations has to sort of start all over again and breaking down those closeout packages and understand the information that's been given to them. And then they have to get that information into some kind of CMMS system that's a maintenance management system, computerized maintenance management system, so that they can actually use the information. And this is all costing, not only does it cost money, but it's costing time where the maintenance staff has to divert their attention over to really data entry work and takes it away from the work that they're supposed to be doing. And so what we found is that really BIM in this whole timeline here is actually meant for operations and facilities management. It's kind of like with the 2D drawings that are normally delivered to operations and maintenance. They rely on those 2D drawings to give them information about the facility. Well, now we're finding that the BIM models, the 3D environment, is becoming as valuable as those 2D drawings. Everybody might not be as proficient as navigating through the 2D drawings, but that skill set is growing. And what they really like is the amount of information that they're getting from the 3D models. It's really that information-rich source of information that they're relying on. So we found that the 3D models, the floor plans, the product information, the warranty information, all of this information is useful in operations. And we found that by giving them this information, they're able to do their jobs much faster and much more efficiently than previously. Now again, when we look at, there's a critical piece that happens here. So if you look at that timeline, again, that 18-month period where there is no information coming in, well, and we say the most expensive part of that is when you replace information that has, when you replace equipment that has failed, but you lack the information to go to the warranty provider or the extended warranty provider. So what this chart is showing you here is what's the equipment failure potential over that 18-month period. And there's actually 3 curves that make up this failure. There's a front-loaded, back-loaded, and a front-end back-loaded. But for this purpose here, we're just going to talk about very quickly the front-loaded failure rate. And this is where we're showing that the equipment has a high potential of failure in the first few months of operations. The other 2 charts show where as the life of the equipment is nearing its end of its life, then the equipment will start to fail, okay, which is sort of an expected outcome. But in this case here, it could be a brand new piece of equipment, some kind of defect in the equipment, maybe, and that's going to trigger the equipment to fail in some way. Now, it may not be that the equipment is completely unrepairable, but the equipment goes offline, okay, and it's not available. And typically, if you have a warranty or an extended warranty, there's a service contract or a replacement part contract that goes along with that, and you can get those parts replaced. But if the operations and maintenance team doesn't have that information, then they're just going to go ahead and replace the equipment. They're going to do the most expedient thing that they can. They're going to go to the Grainger catalog, get a new part in there, get the equipment back up and running. And now all that money you've spent on warranties and extended warranties has been lost. So we really call this period here is the operational blind spot. And this is just where, operations is operating in a vacuum of information. But there's a better way, okay? And this is really the heart of what we're going to be talking about today, which is how do we make this process more efficient for operations? We understand we've got cost savings that we've achieved from the BIM process in design and construction, but how do we realize those savings in operations? And so what we're looking at here is putting the BIM process at the center of the entire life cycle. So we're talking about the conceptualization analysis, the design documentation, the management and construction, commissioning process, and now we've introduced a new area which is called the data transition. It's making everyone aware of how the information is going to move from that post-construction, post-commissioning process into operations and maintenance. And then we have the dotted line here to connect operations and maintenance with the conceptualization and analysis, because we have that ability to transfer information back from the operations system into your Revit models so that you can use it for renovations, new construction, anything you want to use it for. So it's that bi-directional flow of information that allows us to complete the circle of the asset lifecycle. And so what we're looking at here is we're using ModelStream as the engine for the transfer of information, and then what we're going to show you is using IBM Maximo as the maintenance management system that's going to receive the information and bring the information back into the Revit model. So with that, I'm going to turn this over to Steve Martin, who is going to show us how the ModelStream software works and walk us through some of the scenarios.
All right, thanks, George. I'm just going to get my, start presenting here. Looks like it's loading up. Okay. So we're about 20 minutes in here. This should take 20 minutes or less, but Again, this is Steve Martin. So what I'm going to be showing you today is a demo of how ModelStream synchronizes data between a BIM model in Autodesk Revit and IBM Maximo. So first we're going to cover sort of the end result and how ModelStream was used to load the data. I'll show you what the data looks like once it's loaded, and then I'm going to switch over into Revit and show a little more detail about how that bi-directional mapping works and how the synchronization works. But we're going to start off here in Maximo, and we're going to take a look at a couple assets here. So within Maximo, I'm going to go to the Assets application and begin to list the assets. So this is our demo Maximo environment here. The model I'll show you in a bit is our demo model for these ModelStream demos, and we have already synchronized that model with this Maximo instance once. So these assets came from that model. So I'm just going to drill into one of these assets, an air handler, and review here what the data looks like that came from Revit. So to start out, we'll start at the top here. This is the information for one of my air handler assets. Up near the top here, I'm going to look at the attachments that exist on this Maximo asset record. And when I go in here, I can see that there's a PDF that was loaded. I can load that up. This is this is installation, startup, and service instructions. So ModelStream has the ability when you're loading from Revit to bring across documents that are linked or related to your elements in Revit using file paths. I'm showing an actual document here, a PDF, but we can also bring across what are called URL attachments. So if you have a URL to a manufacturer website, or even a URL to a specific user manual or something online, if you add that to your Revit model and then you use ModelStream to do the push to Maximo, that URL will come across as well and show up as an attachment here in this list. So the next thing I'm going to show here within this asset is its location. So every asset in Maximo has to have a location, and ModelStream makes sure that all assets that are loaded from the model are assigned a location. So if I open the drill down here for this air handler and I show the path to the top here in Maximo, we can see the location hierarchy. So what this is telling me is that this air handler is in the room mechanical penthouse 06205, and the parent of that room is the floor, which would be MSB 6, and then the building is MSB, and we're calling the facility MDSK. So ModelStream will take your elements in Revit, right, that are tagged with locations, that you want to push across to your asset management system, and it will build out the location hierarchy by extracting all of those locations from the elements and then building that structure in Maximo and then putting the assets in the appropriate location in the tree. So those are the basics on this screen. I'm going to switch over and look at the specifications. Specifications in Maximo are just a list of key value pairs where you can store additional information about assets. So if we look here, we see a lot of these key value pairs, and these came from the model. So we can see things such as installation date has a value of December 22nd, manufacturer, model number, etc. We can see a serial number. So all of these were brought across during the load, and this is primarily the data that's synchronized back and forth, and I'll demonstrate that in a little bit. If we switch over from the specifications to this model viewer tab, this is the ModelStream model viewer that comes with the product that adds this additional tab into Maximo. So when I clicked on that tab, you'll see I'm using Chrome here. This is just normal Chrome, and we have a model viewer here that's just doesn't require any sort of plugin. It runs in any browser that has support for WebGL. And when I clicked on the tab, it loaded up the room for the model, which is shown here. So this is building, floor, and room. And it actually highlighted this air handler for me in the model. Okay. On the left here, this is showing me all of those specifications that we just saw in this tab, but it's showing me on the left-hand side of the model here for convenience, so I'm not switching between tabs. If I switch to the element tab here, this is showing me all the properties that were on the element in Revit. So it's frequently the case that you would have, and I can, the Revit model is right here, and we'll get there in a minute, but you typically would have many more attributes or parameters in your Revit model than you would in your asset management system. And it's handy to be able to go back and click on an element and see, actually what are my properties of this asset here. These are sort of the managed set of properties that we really care about. But to be able to go back and look at actual element properties, whether or not this element is an asset in Maximo or not. And, to sort of illustrate that, typically you wouldn't load, all of your pipe segments, your ducts, your elbows, any of that stuff, as assets. But because we have the model here and we have the ability to kind of probe and look into the elements, I can click on some of these pipe sections, and begin to see things like diameter, what the material was, some design parameters. So here's inside diameter, outside diameter, length, etc. So that can add some really valuable context when, okay, I'm looking at my air handler. If it was modeled to that level of detail, basically just to be able to go around and look at what's around it, if it's a duct or a pipe or anything else. So that's the model viewer here. I'm going to switch over to the work orders application in Maximo and show how the model viewer sort of fits into that workflow. So I have a sample work order here. It's just called mechanical inspection. Don't worry about all these other fields. But we have 4 assets that are part of this work order, and most of them are air handlers, but I think we have a couple pumps as well. So what I can do from this work order is, again, go back to the model viewer tab that comes with ModelStream. And this time when I load it up, it loaded up the same room. You'll see it highlighted a different asset here. This is a different air handler. And what I can do is I can actually use this navigator up here to navigate up a level to show the entire floor. And I'll show you why this is helpful. On the left here, these are the assets that are part of my work order, right? So the first one is selected and it's highlighted in the model. As I click through the other assets that are part of the work order, you'll see the model updates and highlights that asset, on the floor that I'm looking at. So this is one of the pumps. And again, if I stop on this pump for a minute, I can go to the asset tab and show the specifications for that pump. These are sort of the asset management attributes, and I can still see the Revit attributes over here. But as I click around, you can see the model updates and really gives me some pretty good context about where these elements are. So this is just, showing how we can limit the view to a particular floor, limit it to a particular room, an entire floor, or we can even load the entire building. And I just want to pause on this for a minute because, I think that, it certainly is a benefit to be tying the data from a model into an asset management system. Because you gain all that efficiency of the data transfer, and certainly you get some nice context. But this view here, when I'm looking at the whole model, sort of shows one of the big challenges about trying to use a 3D representation, sort of for general, for non-BIM experts, right? So if I show the whole model, sure, I can see where this air handler is in the building, but I'm not sure how useful that is to maintenance staff. So, we worked pretty hard in ModelStream to create a way to author these views, right, so that there's no ceiling. You really can craft this to make it look just the way you want it, so that whoever is using this isn't fussing with trying to turn off elements or, be sort of a 3D expert to figure out how to view, what they're looking at. They can always also just go, what was that I wanted to do? Go to a top view here, and it's almost like a 2D, 2D plan at that point. So, okay, so that, that was the beginning. That was sort of showing the end result in Maximo. I'm going to pop over to Revit here and just show how that data got there. So this is the same model. It's a little busy because I'm just showing all the HVAC equipment. I'm in Revit 2016, and what I'm going to do is I'm going to launch ModelStream here and show you how the data setup works. So one of the sort of challenges, in addition to sort of the loss of fidelity in transferring the data when you go from sort of from construction into operations. Another sort of challenge that we wanted to solve was some of the mechanics of just how easy or hard it is to get the data in. Most people have heard of COBie. Our consultants, have to use it on behalf of our clients a lot. But we actually thought there would be there was an easier way to transfer the data. If you're able to use your model as the data repository, we thought it would be most efficient to just go directly from the model right into Maximo and just skip the step of possibly messing with your model to reorganize it, exporting to Excel, giving that to someone else, re-importing from Excel, and then sort of rinsing and repeating that cycle over and over again. So when ModelStream is running in Revit, we're actually making a direct connection to Maximo. You can have multiple, configurations for a model. Maybe I'll go into that a little later, but needless to say, when I hit connect here, we're connecting to a live Maximo instance, and we're going to be able to do the mapping and interact with that from within Revit. So I have a small mapping here that I'm going to go through, and this really just has the air handlers and pumps. So the mapping is really at the heart of how the data exchange works, and it just boils down to creating a mapping essentially between objects that exist in the BIM model on the left here and asset types or records that exist in the asset management system, which were on the right. So the first step in this process is to take families, which are on the left here. So this left-hand pane is showing me my current Revit file, each category within the file, and then within each category, every family. And then on the right-hand side here, this is showing me the hierarchy of asset classifications that were just retrieved from Maximo. And the first step here is to look at my families in Revit and indicate where this family should go when it gets translated into Maximo. So for example, we can see here that this family AHU2 has been mapped to an asset classification air handling unit. And this pump, this family named pump-base mounted in Revit, has been mapped to the pump classification in Maximo. So there also is a mode that ModelStream can run in, where instead of doing this type of mapping where you go family to classification, where it will read a parameter on every family in the model, and if that parameter matches the name of a classification in Maximo, it will auto-generate this mapping using conventions for the parameter names. But for now, let's just say we're doing this type of mapping. I'll add some here just to show how it works. Let's say we wanted to add VAVs. I'm just going to drag that across these two VAV families and map them to this asset type VAV. So now that we have the families mapped to the asset classifications, the next step is to map parameters to the attributes in Maximo. So again, when I select AHU2 on the left, that's a family name, and what I'm seeing in the middle pane here are the parameters on that family. And then on the right-hand side here, these are the available attributes for the classification air handling unit, which AHU2 is mapped to. So those mappings are created. I'm just going to show how to do the VAV. So I'm going to select both of them. And I'm just going to create the mappings here. So I have parameters in the middle for my VAVs. I'm just going to go down the list and say I want installation date to go to install date. I don't think last inspected is in my model, but we'll do manufacturer, we'll do model, MSI, serial, and we'll add warranty in there. So that's really it. The last step here, I have the ability with each configuration to add a filter that allows me to specify a parameter, an operand here, and a value that will act to sort of restrict what's being exchanged as part of this configuration. But I'm not going to set that right now. So that was a little bit about the mappings. So the next thing I'm going to do is, we showed how the air handlers were mapped. What I'd like to do is just do a quick demonstration of how the actual values get pushed across. So I'm going to pick this air handler, which I happen to know is AHU06. I'm going to look at the parameters here, and it has a warranty start date of January 1st, 2016. So over in Maximo, I'm going to find that air handler, which I know is 06. I'm going to go over to the specifications. We can see that same value here. Warranty date is January 1st, 2016. So just for the purposes of this demo, I'm going to change it to another date, February 18th, 2017. Let that go. And now I'm going to use ModelStream. Again, I'm just changing one parameter, and I'm just going to push that across, but this could be any number of changes. So I'm going to go in here, and instead of editing mappings, I'm going to export to Maximo. It's going to tell me I need to save the model. It's going to give me a little preview, so I only edited one asset, so it's saying, oh, we're going to push one asset across. I'm going to do that synchronization. It's pretty quick. I'm done. And I'm just going to go back into Maximo here and refresh this record. And I'm just going to go out to the list view, step off the record, and go back in. And you can see that the date has changed, right? So a trivial example, I changed one parameter on one asset, but in Revit, I could have a schedule of these air handlers. This is just a demo, and I could change all of these right in the schedule and then push them back to Maximo. So the last thing I'm going to show here is what we call MX parameters. So if I go back and look at the specifications here of my air handler, we have a specification that says the number of work orders that were executed in the past 6 months. So this is an example of an asset property that could be calculated on an ongoing basis. It could be so this is something you wouldn't maintain, in Revit. This is sort of something that is intrinsic to the asset. But maybe we want to see that in Revit. We want to bring that into Revit, and maybe we're going to make some sort of thematic view for the purposes of a presentation. So I'm going to go into ModelStream again. And I'm going to create what's called an MX mapping. So I'm going to come in here, and I'm going to bring work orders in the past 6 months in. I could also bring last inspected. Okay, so we say MX. It's a way to indicate that these parameters didn't start in the model. They came from ModelStream or Maximo, thus the MX. And we just want to make that really clear. But what's going to happen is by selecting these two fields, I'm going to bring the values, I'm going to create new parameters in my model and bring the values from Maximo into my model and populate these new parameters. So now when I say import MX parameters, now if I select my air handler and scroll down in the parameters list on the left, you'll see I have a couple new parameters here. They're prefixed with MX, again, so that it's totally clear, where these came from. but here are my values that I brought in, and we can just go over again and compare these. We can see 4.1 is last inspected on in the work orders in the past 6 months. Yeah, if I actually have to look over here because it's numeric, is 1. So that's it for the MX parameters. The very last thing I'll show here is just a little bit about how the location hierarchy gets created. So if I go into the settings here, I mentioned how the locations get sort of built out in Maximo. You set this up in ModelStream basically by just selecting what would probably be project parameters in your model for each level of your hierarchy. So in this model, we happen to have a parameter called loc building, loc floor, and loc room. And you indicate what delimiter you want. You'll see this as a dash. And if we go back over to Maximo again, and I go back to the asset record and look at the location here, you'll see that this is how it was built with loc building, then a dash, building is MSB, then the floor 6, then the room, which is mechanical pent 06. So you can have up to 7 levels here. You can also build out a hierarchy starting at a particular location. So obviously if you have an existing system and you're building out a new campus or a new set of buildings, you can configure ModelStream here to say, well, start with the root, insert these new locations, in this particular, with this particular parent. And then this last option here, ModelStream can either create locations as it needs to, or if there's already an existing Maximo environment that has sort of a change control process around locations, and you want to just use existing locations and not have ModelStream create any, you can switch to this other mode where ModelStream will just look for existing locations, and if they don't exist, it will let you know, so you can go in and create them. And this is really just for, again, scenarios where, maybe the IT administrators of the Maximo system, they have a special process for, provisioning these locations, and they want to keep that control. So that's really all I wanted to show for the demo. I'll pass it back to George, and like George mentioned in the beginning, there's a questions panel here in the little webinar control panel. So if you have any questions, just type them in there, and we'll address them at the end. Back to you, George.
Fantastic. Thank you, Steve. That was great. I don't know about you guys, but software, this kind of software to me is really exciting. I mean, the iPhones are great, but I think this is way more exciting from a real-world, productive perspective. So, great, a lot of good information. So, just to kind of recap a little bit of what we're talking about here is, we've got ModelStream will create the assets, update the asset attributes from Revit, do the location hierarchy creation, and then Steve was showing in the beginning that the links that are in the Revit model will get carried over to the Maximo system, so that the O&M manuals, the cut sheets, things like that, the information that the operators need is carried forward into the asset management system. And then the critical thing there is it's the bi-directional synchronization of the assets and the location data between IBM and Maximo. So very quickly, how does it start to address the problem that we're talking about here? So we go from, and this is sort of the big picture context of things. We go from the post-design, construction, as-built models, the operations and maintenance sync, operations and maintenance, and then ongoing EAM, enterprise asset management and performance monitoring. So in that we have Revit. We create 4D, 5D, 6D models. Maybe use BIM 360 field tools for the commissioning process. All that information feeds back into your as-built model. And then we use ModelStream and Maximo to transfer that information from the as-built model into operations and maintenance, and pull the information back and forth. So the key here is that all the data is handled electronically. There's no need to rekey the information and again, we're trying to achieve that smooth curve that we showed in the very beginning, where you have a seamless transition of information, and ModelStream gives us that seamless transition. We'll just recap a little bit here on a couple of real-world scenarios that we've gone through recently. New construction here. This is a bridge project that we did. It was actually the new Goethals Bridge, which is the first bridge in the New York region in like 60 years. So we did, an analysis of the design model. We were given a design model. We did an analysis of that model. We created a structural member naming convention for it, and we migrated the structural assets. So each one of the structural members that you see in the pictures, they actually became an asset within the system. So we loaded about 4,000 assets overall as a result. We put ModelStream in, the model viewer in, all total about 4 weeks' time from start to finish. Very efficient process, very easy. The mapping is created once, and then you reuse it over and over again for each section of the bridge. And then in terms of a renovation project, this is the way that Denver International Airport uses it, which is where they'll take the information from the operations and maintenance system and feed it back into their Revit model. So the Revit model has the up-to-date information about the current facility conditions. They then hand that information off to their design team. The design team comes up with the new design, the renovation. They construct it, they make the renovation, the changes, and then they feed that information back over into Maximo through ModelStream, just completing the circle. So in terms of renovations, it's a very quick timeline for doing this work. Maybe it's rerouting air handling units or something like that, or VAVs that have to get rerouted. Very quick, easy stuff that they use it for, and it allows them to very quickly capture the operations information and update their system with the new information after the changes are done. So just in summary here, the goal that we have here is, the as-built model that we talk about in the industry really now becomes the record model. Okay, and now the record model is relevant for the entire life of the facility. So again, that facility that's operating for 20, 30, 40 years can have a Revit model up to date every year with with all the changes. The facility maintenance and operations staff, they get the visualization tool to embed within the Maximo system. They can do their work area verification. They can do the assets in context, which is where I want to see what is connecting to this what kind of piping is connecting to this valve. It's all that contextual information that really starts to drive the cost savings. And so giving them this record model that's dynamically connected to the EAM system, Enterprise Asset Management System, allowing them to visualize, allowing them to see the assets in context. Really, this is what drives the 5% savings annual in operations savings. So this is really key here, that you have an as-built model, it's linked to your EAM system, you're able to improve the efficiency of the operations teams, and then that efficiency translates into a 5% savings overall in operations and maintenance budget. So with that, thank you for your time. If there's questions,